morning, good afternoon, good evening, whatever you have. So let's quickly check this. Can you see my screen now?
Not yet.
Can we see it now?
Okay, now it's showing.
We can see it now.
Yes, sir.
Oh, okay. Let's see whether I can still get. We'll go through some of those stuff, but let's go and solve this one. The one we solved last week. The one I gave you. Now, one of the questions you need to know, or one of the ways to solve this problem you need to know is, what is this question? Is this question first order or second order? Everything will be differential. Don't be deceived. Everything will be differential that day. So if you don't know it, you don't know it. So the best thing is identify them first. How do we solve? Go and master this table, this particular table. I believe you can. All of us can see this table. Can we all see it? It's in your notes.
Yes, sir.
Yeah, go and master the table. It is very important. Where, especially when you are solving, when you are to solve, look at it. Linear differential equation, method of undetermined coefficient. So the table says, anytime I have a constant of g of x, where is our g of x? This is our g of x. The g of x is here. I have this second differential equation, second order, to this one and to ordinary y. And I need to find my y complement. My y complementary you only get this y complementary. The form of equation will determine which of the y particular you are going to follow. For example, look at this. If you have a constant in your equation, you follow this, you represent it. If you have a linear polynomial, if you have a quadratic, if you have a cubic polynomial, if you have all the trigonometry or exponential. So you just have to master this constant practice. Now look at this equation now. We have y prime. In this case, if you look at it from the general equation is the one which equals to g of x. So your general equation, what represents g of x in this case now?
5.
It's 5.
What is our a in this case?
1.
What is our b?
3. Plus 3.
What is our c?
2.
Plus 2.
Now that you're a, you don't need anybody to tell you what to do. By the time you get your y complementary, how do I get my y complementary? Now that I have these two, who can tell me, how do I get to this point? How do I get to the y complementary?
You solved the auxiliary equation.
Yes. So I think we need to go back, because before we solve that, let's go back so that few of us that are here, we can just remind ourselves so that we have idea of the way we do solve them. I think it all started from this side. Am I right? Okay, let's go up a bit. Okay, let's start from, okay, we can still go up. Okay, let's start from here. How many of us were not here? Just raise up your hand. I don't need any more. If you are not here when we solve this, please raise up your hand. Let me see the number of hands. Okay, we only have 2 people, 3, okay. Okay. Now, we are not here. Okay, let's look at this. How do we solve this? Number one thing you need to know, the first thing is you have this equation. I will advise you go and watch the video again and again. You have this equation. Our the P over the T equals to KP. That means we are differentiating with respect to it. So what are the things do we need to follow? Except at this point, what is K? K is the growth of the population. P itself is the population size. We all know the T. We're talking about the time. So in this case, what do we need to do? 2 things. You can multiply, you can cross multiply or multiply through by the T. That is, if I have the P over the T equals to KP, I need to cancel this T because this T is not belong to this place. The only way I can cancel it by multiplying by the T, both sides. So it's in this one we cancel. And you have the P alone equals to KP dt. But the question is, P is supposed to go to P and constant, the K will stand alone. How do I do that? I know I can only divide this one to cancel here. Then I must divide here too. So this one will go with this. So that is why we now have 1 all over P dP integral. We now integrate the both sides. Because it is only integration that can cancel differentiation. Have that one at the back of your mind. Integration cancel differentiation. So if I know integration cancel differentiation, I don't need to struggle. So if I want to integrate this one, don't forget integral from the knowledge of calculus, integral of 1 all over x dx is the same thing as ln x. The same thing happened to the 1 over p. The integral of 1 over p is what? Ln p. Then I know k is constant. I can easily, it is only when you differentiate k that it turns to 0. But when you integrate k, from the word integrate, it increases. Increments happens. So it simply means I will have k, integrate the t. Don't forget, you can separate the t, you can separate k out, but integrate this. What does it mean? When you integrate, I just told you that integration is anti-differentiation. So if I integrate the t, it will cancel the differential equation that belongs attached to the t. That's just the meaning. Ln p equals to k, differentiate this one, you have ordinary t plus a constant. So how do I go about this? From here, I need P. That is my target. You cannot get the P. The only thing that can eliminate ln is exponential. And the only thing that can eliminate exponential is the ln. So you can see the two work in hand. Then I can now say take exponent share of the both side, because what you do to the right side, you must do it to the left side. So if I take exponential of the both side, I will have ln p equals to exponential kt plus c. That means this cancel this. I now have p equals to exponential of k t plus c. But mind you, we have a law that says, according to the law of indices, a raised to power s multiplied by a raised to power y is the same thing as a raised to power s plus y, right? Then I use this principle against this. So it simply means this is e raised to power kt plus y. I can write them in this format. That is why you can see us say P is equals to, this C can also stand alone by saying that my C, let me just take this one back to this place. It's the same thing by saying e raised to power by P is the same thing as e raised to power kt dot e raised to power c. And don't forget, exponential of constant is still constant. That is why you see us say P equals to C exponential kt. That's all. So if you can get the principle behind it, there's no question you will not be able to solve. So that is what we did initially. That was the background we laid early in this semester. Then we now said, okay, what even is the P, is the C? We can get the C by making our initial time to be 0, because T is initial time. If T is equal to 0, anywhere I see T, substitute 0. I put 0 here, it turns to P of 0 equals to C, T multiplied by K is 0. Anything raised to power 0, exponential raised to power 0 is what? 1. Press your calculator, you will get 1. Then I can proceed by saying 1 multiplied by C will give me C. It simply means that P naught, that is P of initial condition, is equals to C. Then anywhere I see C, it simply means initial condition, population. Then that was what we did. Any question on that? Any question? So that is just the simple thing that lead us to the same thing. The same principle is the one we embark on. Look at it. Is everything we did initial value problems. That is how we solve them. And we lay the foundation. You see? You see the foundation? It's the same thing we did. It's the same thing we did. Yes, if Belero, you raise up your hand.
No, it was the time that you said we should raise up our hand.
Okay.
We're not in the last class. Yeah.
So you discover that that is the method we use. Then that now leads us to this integrating factor, because that is all you need to know, the principle of integrating factor. And because that is the only thing you'll be using throughout. Now, how do we do integrating factor? Your equation is of this form. You have your y prime plus p of x, y, equals to q of x. Our integrating factor is very simple. We take our p of x. Anything that is here is your p of x. It might be 1, it might be -1, it might be 2. It's your negative of x. It's your p of x. So we go ahead, substitute it. How do we do that? The integrating factor is the same thing as I of x equals to exponential of integral of p of x dx. All you need is just integrate p of x. put it back on your integral function and substitute it in integrating factor. That's all. By the time you do that, look at this one now. When we are given this question to solve, we first of all know that our y prime must stand alone. What will make my y prime to stand alone is divide anything that is there, eliminate whatever that is attached to it. That is what I did here. We did this because we know x minus 2 is attaching to y prime. First of all, eliminate it. Divide both sides. That you must learn that. You divide what you are doing in the left must be the same thing in the right. That is, divide both sides by x minus 2. It is pretty simple. So when we divide both sides by x minus 2, what do we have? We have this. But difference of 2 squared, x plus 2, x minus 2. Then let this one eliminate itself. At the end of the day, your equation is this. Don't forget, it is y prime plus p of x, y equals to q of x. That is the general equation for this particular problem. So I need to identify my p of x from this. My p of x is 1 all over x squared. Then my q of x is what? S plus 2. Then substitute everything into it, into p of x. Just all you need to do is just to integrate this one alone and put the answer back to this. When you integrate this one alone, what do you have? You have this. Then I taught you the earlier on that exponential will cancel the ln. So take exponential. We have the exponential ln x minus 2. This one will go, and you are left with this. That's why we put this condition there, so that you understand what it simply means. It simply means integrating factor we have now is I equal s minus 2. So in case if you have this one, we can go ahead and substitute. This is a general formula. Substitute it here. And at the end of the day, all you need to do is just to multiply, integrate, multiply, just integration, simple integration here, and you are gone. But in case my question is not that straight, the way I explained, this is another type. Just all you need to do is make sure you have your dy dx, like this y prime. You must restructure the question they give you, you were given, to have the y dx prime. Once you know that it's a first order differential equation, make sure you find your way. You use integrating factor to solve them. And you know that first order differential equation is y prime plus p of x, y equals to q of x. Simple. Second order differential equation, that's where you have different methods of solving them. You can have idea the way you solve it. It is not how far, but how well. You might have the question, you have the method, you might not know they are talking about the same thing you know. So how do we solve this one now? Now you are given the hex. Once you see the hex here, it simply means something is missing somewhere. How do we fix it? You know we have y prime. It simply means y prime means the y over the x. So, excuse me, it simply means the other side, there is a y somewhere. The y is there. So all I need to do is, first thing is divide both sides by the x. Divide both sides by the x. When I divide both sides by the x, what do I have? The s is being eliminated. I have this. And I know the y the s is equals to y prime. So, and I have this. Everything equals to 0. So, I can rearrange my equation quickly. I know the other side of my equation is not qy, is qx, meaning anything that have x will be the one that will transfer to the other side. That is just simple. Now, I have 4y minus 3x. So take the x to the other side, it will be your qx. Automatically, you already formed this equation. And don't forget, y prime must stand alone because of our general equation here. For y prime to stand alone, I will still need to divide both sides by 5x. So that is why you see us dividing each equation by 5x. Then we have this. S will go with x, you have 5/3, and this one will stand alone. It simply means, you see, we still use integrating factor. All you need to do is just to strive to get this out. Then integrate 5/x. You have 5/4. It's not hard. Don't think it's hard. All you need is just to be explicit. Don't rush to finish all. If it's you can select the one you know, solve it with all your heart. Don't join the background, be clicking and clicking. No. What's the difference between you and those people that are playing Baba Jebu on the exam? Playing the lotto. So the difference must be clear. You must know what you are doing. Identify the question, apply the method, solve it. I'll share one of the experience with you, probably after this. Okay, there was a time in Nigeria, I applied for a job at a bank. And in one of the banks, I haven't done first order, but the first degree order. Says who? Charles, are you there? Or you are back to your business?
I'm here, sir.
Okay, I'm hearing you.
From what you are doing, I noticed it's like what we are doing today is a revision. So I
We are
discovered
not
that
doing revision. Yes, it's a revision 1. I'm still going to the question I gave you to solve. I'll solve it because I just quickly use that period to explain some of those things so that those are joining for the first time will also have a good understanding of what we are doing and motivated to go to the video again. So,
okay.
Are you getting it now?
Yes. So what I was saying in essence is that I noticed there is some topic in the course material, like we have some first order, but not first degree equations. It's like I noticed like we've not said that, sir.
First order in the course material, which of the topics are you talking about?
First order, but not first degree equations, differential equations.
Yes.
Where we use a variable p to represent our dy dx.
Have you watched all the videos?
Yes.
You can use anything to represent the y dx. I use R, I use M, I use anything. Are you getting it?
Yeah.
We'll solve it. We are going there now.
All right.
It's there. This is the black, but this is the board I use, and it's there. And it's a pity you miss a good number of classes, so due to your business. Anyway, let's continue. I will tell you the story later. Let's quickly do this. So when you integrate this one, this is what you have, and you substitute. It is not hard. All you need to do is just to lay the foundation. Look at this one. This is another type. Get your cross multiply, get your y prime, take it to the other side, and so on. These are you need to go back to the video. For those of you that have not been here for ages, go back to the video and it will help you. Are you getting it now? Somebody says it's no longer hearing me. I hope all of us can hear me.
Yes, sir.
Oh, okay, please check your phone. Is that okay? Okay, so we have the same. Now, when you are talking about particular solution, remember this particular time we solve something like this. You have the general solution, we have the C, we have a particular solution means y complementary plus y particular. So that would now turn to your general solution. The initial value problem is when you are given x to be equals to something and y equals to something. Is there on your past question. After you've solved your equation using different methods of solving them, you have your general solution. All you need to do is find your C. What is your C? That is when the initial value problem comes in. So we have all this. Then that leads us to the particular solution we're talking about here. And the one I explained earlier on, which is application. Go and check the application. You will surely get the application on that day. Then that leads us to separable variable method. So you can also use the separable variable method, which we've been using anyway. Then we move to homogeneous equation. After the homogeneous equation is just in homogeneous, we let V equals to y over x, and you differentiate and so on. It's like a quotient rule. You apply it, then it now lead you back to this equation where you get your y's complement and y solution. Homogeneous equation here. So please try as much as possible to go through all the videos. They are available. You can pause it at your own time. Then will lead to exact differential equation, whereby we know whether equation is exact or not. So please take your time and do the needful. They are very important to you and to the sources you have. So like this one now, this is what our friend is talking about. Am I right, Charles? Charles?
Yeah, yes, sir.
So you can use anything to represent it. It depends. So I choose to use R here or use M. It depends. Don't just say you must use one. So after you know that this is equation, now this equation, look at this type. Y prime prime plus y prime plus y equals to g of x. How do I solve it? Represents your y prime prime by something, just for you to get your y complex, yc. And I know the general yc is this, because anytime I have y prime prime is a quadratic equation, I will solve it quadratically. It's either you use minus b plus or minus square root of b squared minus 4ac over 2a. If you cannot use factorization method, please stick on it. Don't deceive yourself. You know yourself. Now, this is where you substitute it. Yc equals to C1, because we are doing quadratic, definitely I will get two answers. C1 and C2. So we can solve that and it will make more sense. Then YP is equals to what? We get your YP, you go there and solve your YP. How do we solve YP? Because YP here is what? Constant. And from the table, I told you, anytime you have your G of X, look at this, it's here. When my G of X is a constant, what is going to be my YP? Will be A. If my G of S is a linear polynomial, I will have AS plus B. Let's check. So our YP here is equals to A. When you differentiate YP, when you differentiate a constant, what do you have? 0. When you differentiate second time, you still have 0. Then let's go to equation. Substitute 0 into whatever you have here to find your A. And we are able to get our A to be 5/2, which is equals to our YP. Then the general solution will be YC plus YP, that is Y complementary plus Y particular solution. Then we add it together. But in a situation whereby your G of S is a linear, excuse me, if my G of S is a linear equation, what do I do? What is linear? Linear is when your S, the highest power of X is 1. So it simply means my YP will be of the form of this. That is AX plus B. AS plus B. Then after you solve for your Y complement, look at it, we still use quadratic equation to solve it. Remember, your Y complement is what? C1 exponential alpha X plus C2 exponential alpha X. What is my alpha? The first alpha is -2. The second alpha is -1. Substitute it, write it there. My G of S is this. It simply means my YP is equals to this. This is the one I will differentiate that will give me first differential equation and second differential equation. Let's take note of this. Then when I differentiate this one, I will have A. When I differentiate the second time, I will have 0. Substitute it into equation 2 that you have up. What do you have? You look for your A and you get your A and B. So I have my A to be 2 and I have my B to be 1/2. Substitute it back into this equation. That's solution for you. You will have so many questions on this platform, on this type. Go and learn how to solve it. They are very simple. Don't join the background that are shouting, it's too hard. It's not hard. It's because some of them are lazy. Now, in a situation whereby our G of F is a quadratic, go back to your table. That is why you need to master the table. Look at it. When it is quadratic, your equation will be of this form. AX squared plus BS plus C. So I will still differentiate AX squared plus BS plus C. So that is what I will differentiate. So I will now differentiate first time. I will have 2AS plus B. The constant returns to 0. Differentiate, when you differentiate this one second time, what do you have? You have 2A. Then I can go to my equation. This is my equation. I will substitute all my differential equation inside, where you have Y squared, Y prime prime, and Y prime. And your Y itself, which is your YP that you pick from your table. You substitute it here. Then you equate, you get all your constants. And that settles it. We did the one of exponential too, because I make sure we did one question on each of them. So, and this is the classwork that I gave, I remember. Some people responded, while some did not. Thank you so much. So that is major summary we have. Then that leads us to all these cause variation of parameter. We solved something on variation of parameter too. So let's move on to today's problem. I think some of my work, we jumped the board sometimes ago. How many of us remember that day where we are looking for all those things? So we have this, we've done something on Rakati differential equation. Go and learn this. They are there. You are so lucky. Bernoulli is there. Please learn. Try and pause your video. They are there. You have the link. Carrot is also here. Please go and substitute them. For those of us that have, if you can lay your hands on the link, the YouTube link, if you cannot go to your video. Now, this type, the coaching Euler, you will need all these in the future. Let's try homogeneous and non-homogeneous. So I gave us non-homogeneous question. So how do we solve this one? Then don't forget we did Roxian also method. Excuse me. So we have all this. This is assignment that I gave you. Are we all there now?
Yes, sir.
Okay, let's quickly look at this assignment. Remember the general form. Yes, what's the question all about? Somebody is asking for the YouTube link. Are you not on WhatsApp? Are you not on WhatsApp? If unmute yourself.
I'm there, sir.
So you don't see the video on the WhatsApp? I mean on the WhatsApp for the group.
Okay.
Hey.
I saw it, sir.
Okay. So you've been seeing the WhatsApp and you did not know that is there. Okay, that's interesting. So let's solve this solution. We have it to be. Thank you for those that have responded. But for those of us that we are not yet, we are nowhere to be found. Thank you too. You have x squared y prime prime minus 3xy prime plus 4y equals to x squared. The first thing is, what is general solution, general information for this? Ax squared y prime prime plus bx y prime plus cy equals to g of x. All we need to do is to equate, if it is homogeneous, you equate it to be 0. But in this case, it's non-homogeneous. But you will still need to solve it in homogeneous way first. That is, we need to solve it in homogeneous way by saying that we have, what is our A? Our general formula, the one we prove, is what? Who can remind us? Anybody?
Hello.
Yes, go ahead.
Okay, the general formula is am squared plus B minus
Just hold
A
on,
bracket
Ibrahim.
M.
Just hold on. I'm coming, sir. Just hold on.
All right.
Let me just show someone here, so that before they crucify me, that which one is this saying now? Okay, look at it. We started the proof from here. Cauchy-Euler second order differential equation. So we say that homogeneous is when G of x equals to 0. That is where they said a particular equation is homogeneous. Then when they said non-homogeneous means the G of x you are seeing out there is not equals to 0. Then we have this formula and we have this equation. They now said, okay, let's represent them. Let y equals to s raised to power m. Then differentiate your y. Y prime will be m x this. Y prime prime will be this. Then substitute it into your equation. When you substitute them, what do you have? You have all this. Open the brackets. Just mark them one by one. From here to here, what do we have? Remember, this is bs raised to power 1 dot bm minus 1. So it simply means that I can say bs m minus 1 plus 1. So I will have b s raised to power m. That is why this one b like this. The same thing happened to this. The same thing happened to all of them. Don't forget, part of the steps is to make this homogeneous for you to solve first. Then at the end of the day, we have a common ground. Something is common. S of m is common. S raised to power m is common. Divide through by s raised to power m. Then we are left with this. And since we already solved this one, it is okay for you as individual to be using this to solve other problems. You don't need to pass through all this because you are not doing paperwork and you have a lot of questions to answer. Are you getting it now? So in this case, for homogeneous form that is distinct real root, when your m is in distinct real root, that is you have your m in two ways, you use this one. And look at this condition. Remember the quadratic equation. Go and check it. They are there. So when you now have your am squared plus, that is the equation triangle will be the one you'll be using all through. Because you don't need to pass through all these, match the power again. So you use it. When you have a repeated, when your homogeneous is in repeated form, that is, you have y equals to c, that means you are going to use our yp to be this. Repeated real root, that is, you have, let's say you have 2, 2, or you have minus 2 or plus 2 as your final answer for your differential and for your quadratic equation. So you use this form to write them. You use this form to write them. So, and when we have a complex, you use this form to also write them. But let's look at the one we are given. Yes, Charles?
I want to ask from what you said, sir. When we get, for instance, our value as minus 2 and plus 2, is that a repeated root?
Yes.
Minus 2 and plus 2. Minus 2 or plus 2?
Yes, they are repeated real, not repeated real roots. So that is, remember, you can't get 2, 2. Is either positive or negative? Do you agree with me?
Yeah, yes.
In quadratic equation. So you have, it's either positive or you have negative in most cases. So you have this. When your quadratic leads to what do we call it now? complex. How do we get to the complex? Look at this problem. Look at this. You and I know that square root of this will lead us to the what do we call it now? Complex analysis. Then you can take this one out. Find the square root of this. Find the square root of 4. You have 2. That's why you can see 2 here. Then we don't need to prompt calculator. We know as a mathematician that -3 will give you 3i. Then factorize your 2 out so that in order to eliminate this one. Now, don't forget the complex says is of this form. Now, what is alpha? Identify your alpha and identify your beta. Then substitute it to the general formula. This is the general one. Substitute it here. Are we together now? Hello?
Yes, sir, we are together.
So that's continuous this way. But for the non-homogeneous, these are the steps you follow. And from these steps, you can now lead it to be able to solve the problem one after the other. You follow the Roxian method, get your YP. Your YP is U1, Y1, and let's solve it. So once you're able to solve that one now, so Ibrahim, go ahead, tell us the general one.
Okay, the general formula is AM squared plus open bracket B minus A close bracket M.
AM squared plus B minus
Open
A
bracket, close bracket M plus C
equals to 0. Okay. So what do we need to do at this point is to
identify our A. Yes.
Identify your A from your equation. But that what's going to be our A in this case from here?
1.
A is equals to 1. Then our B is equals to what?
Minus 3.
Minus 3.
Then our C is equals to
4.
Let's substitute it. We have it to be M squared plus minus 3 minus plus 1.
Minus 1.
Minus 3.
Minus 3 minus 1.
Minus 1.
Yes.
M plus
M
4 equals to 0. M squared minus 4M
minus 4m plus 4
equals to 0.
So in this case now, we have multiplicity of 2 altogether. So we have it to be M minus 2 all squared equals to 0.
Yes.
Am I right?
Yes, you are correct.
So what do we have at the end of the day? What is our M?
M will be 2
M
squared.
equals
Twice.
M equals to 2.
Twice.
We call it multiplicity. Charles,
Yes, I'm with you, sir.
you remember the question you asked now?
Yes, I remember.
So if I may chip in something, sir.
Okay.
I think the question Charles was asking is if you have your root to be minus 2 and plus 2. And he was asking if that is repeated. I think the answer is no. That is 2 distinct real roots.
No, I thought he said when you have 2, 2 or 1, 1, or what is the question, Charles?
Yeah, that was what I asked her. Minus 2 or plus 2.
Oh, Okay, sorry for that. Thank you for that observation. I didn't get that. I was thinking you are talking about plus or minus. That was why I mentioned you can have plus or minus. Thank you. So you can see the situation whereby you have this particular format. And don't forget, you have x squared, c1s squared, plus what? c2s squared.
Ln x.
Ln, not ordinary ln x, ln absolute value of x, because anything can happen to your ln x.
I know.
Are you getting it now? So yes, in this case now, how do we solve this? We have our yp to be what?
u1, y1.
u1
plus u2,
y1 plus u2 y2.
y2.
So how do we solve?
Our y1 is x squared.
Now, you need what we call the reduction using the variation of parameters way. Yes, go ahead.
I was thinking the two parts we have ln x.
No, only one part.
Okay.
Go and check your book. I'm not sure whether your book captured that or scatter everything. But you have 0, y2, g of as squared, y prime 2. Then our y2 will be y1 0, y prime prime, g of as squared. So this is the method we need to use now.
Okay, so I just discovered that was for complex root. I just saw that now.
Okay. So now we can proceed. How do we solve this problem now? Who can tell us what to do? We need what? What do we need at this point? Here, what is our y1 here?
X squared.
What is y2?
S squared ln x.
Please take note of that. So we can now differentiate y1, our y2 now, and y1. Let's differentiate y1. What do you have?
2x.
When you differentiate y2, what do you have?
Applying product for it. We're going to apply product to solve that.
When you differentiate y2, what do we have?
2x.
We have 2x.
Do you know y2 is what?
Product rule.
Product rule. You differentiate one, you hold one constant. Are you following?
Yes, sir.
Let me first of all differentiate. You have u and b. I can say 2s ln x. I hold this one constant. I will now say plus holding s squared constant and differentiate this. What do I have?
1 over x.
Then y prime 2 is equals to 2s ln s plus x. Do we agree?
Yes, sir.
So, okay. Then we can now get our w first. W will be what? What is y1?
S squared.
Y2.
S squared ln x.
Y prime. Y1 prime.
That was a 2x.
So using determinant theorem, so we have to be s squared in brackets 2x ln x plus x minus 2s into s squared ln x. We can open the brackets. I have 2s cubed ln s plus s cubed minus 2s cubed ln x. At the end of the day, this go with this. So our W is equal to S cubed. Do we all agree?
Yes, sir.
So we need to get G of AS squared. What is our G? Our G of S is what? This is your G of S.
S squared.
S squared. And our A is what?
1.
S squared divided by S squared. So everything here is 1. So we can now do the omega 1 or W1. The formula of omega 1 is, well, W1 is what? 0, Y2. 0. What is your Y2?
S squared ln x.
Then what is G over A squared? AS squared?
1.
1.
1.
Then what is Y prime? Y square prime?
2x ln x plus x.
So when you find out that this, you have to do this.
That's 0.
0 minus S squared ln x. So our W1 is what? Minus S squared ln x. So the next thing is Y2, W2 rather, which is, what is the formula for W2?
Y1.
What is Y1? S
That's
squared. What is
That's 0.
0? Then the next
Y1.
Y1 prime is what? 2x. And G over AS squared is 1.
1.
So we have it to be what?
That will just be S
2x
squared.
minus S squared minus 0, which is equals to
That'll be
S
S
squared.
squared.
And don't forget, our Y,
U
we
prime.
are U prime. U prime 1 is equals to W1 over W.
W.
W1 is what? Negative S squared ln x divided by S cubed. So which is minus ln x over x.
Over x.
That is my Y prime. I can integrate Y prime. I will have the x, right? When you integrate y prime the x, what do you have? It equals to u1. So which implies that integral of minus ln x over x. So what is the integral of minus the s over s dx? Then you have to use substitution method for you to easily get rid of it, or else you'll find yourself hooked somewhere. Let u equals to ln x. Du ds is equals to 1 over x, and du is equals to 1 all over x dx. So in this case now, what is the u? We can go back to the equation by saying that I know that I can easily solve it. How do I solve this one from here? What is the s? Anybody?
The x. This will be du over. Okay. X du.
S du. We have s du equals to the x. So you can substitute it, right? So you have it to be integral u. But don't forget, you can put this one there. 1 over this one, but like this can be u du. Do you agree?
Yes, sir.
Then integrate this one. You have minus u squared over 2. What is my u?
Ln
I
x.
know the u to be what? Negative
u is ln x.
ln square x over 2. So in this case now, that is our
u1.
u1. Then for u2, u prime 1, u prime 2 rather, will be what?
w2
w2 over w equals to what? What is w2?
X squared.
Is what? S
X
squared.
squared.
Okay. You have s squared over s cubed, which is 1 all over x. So I can say integral of u2 will be equals to 1 all over
Ln
this,
x.
the x, which is what? Ln x. So we'll go to our general equation, substitute it there. Yp equals to u1 y1 plus u2 y2. Excuse me. Is equals to u1 is what? Negative 1 all over 2 ln square x, absolute value, don't forget. Multiply by y1 x squared plus what is the 2? u2
Ln x.
ln x, right? Ln x
Yes.
multiply by what? y2. So at the end of the day, we have the half of this. When you open this bracket, what do you have? Let me write it so that you can get what I wanted to do. minus 1 all over 2 ln square x squared plus, when you multiply this one with this one, you still have ln square, right? So this is a O1. This is 1 minus half. Are you getting it? So our YP will be 1 all over 2 x squared ln square y x. So general formula is y equals to yc plus yp. General solution will now be, we have our y up, yc up, c1 s squared plus c2 s squared ln x plus 1 all over 2 s squared ln square x. Any question? How many of us got this? Raise up your hand. Ibrahim, I saw you send your own this morning.
Yes,
Charles,
sir.
you did not send it to me. You mark it by yourself. See this one. See, hey, Emmanuel, you are enjoying. That's good. Yes, Ibrahim.
No, you said we should raise our hand if you got it.
Oh, okay. Only you, Kausara, did you try it?
Yes, sir, I did try it, sir. Good afternoon, sir.
Okay. Did you manage to get it? Or
Yes, sir.
okay. Oh. For those of us that try it, good luck. For those of us that we did not try it, also good luck. Fola Shade, how are you today?
I'm fine, sir.
You're welcome, man. Pascal,
Thank you.
are you there? Bisola?
Yes, sir. I'm here, sir.
Oh, okay.
Yes, sir.
Finyi, can you talk now?
Yes, sir. Yes, sir.
So why are you just joining the class for the first time?
Actually, sir, my phone got spoiled, so a friend just linked me up with a WhatsApp platform. So
Does it mean you've not been checking your module, your platform?
yes, sir.
Good student.
I'll do it to check the videos and
Which center are you from?
Abeokuta, sir.
Okay. Just go to Olumo side. You will get the inspiration. You just be writing. So let me just share the screen again so that you can see what I'm seeing here. Can you see it now? Hello?
Yes,
We can
but
see,
it's
sir.
blur.
Now, they said represent the change of population, P of T, with constant births. And the death rate is proportional to the size of the population. I just show you in the slide. The P over the T equals to KP. They are there. So you should know how to write those equations.
So this fraction that is in front, okay, just means the division sign.
Yes, it means anywhere you see fraction means division signs. Thank you. They use letters to type it. It simply means dp over dt equals to kp, or dp over dt equals to k minus p, or dp over dt equals to k in bracket 1 minus p. Is
So
that
there's something I want to say. Ask. Hello, sir.
I'm with you? Let me just
So
explain
this one
this.
that
I'm coming.
okay.
So,
Okay.
like this one now, the answer is a solution. Look at this. M. Find the value of n so that the function y equals to e raised to power mx is a solution of the differential equation of this form. Who can tell me this? Do you remember? Who remember this question? Nobody.
I'm currently on the road, so I can't see the screen clearly.
Yeah,
So that's
sorry for that. So
why.
Charles, are you there?
Sorry, sir.
Pascal.
Yes, I'm here. I'm here.
So what is this? Kausara, what is this? Bisola, what is this equation? Write it down. Where they put mx, it simply means the same thing we are using. Y equals to e raised to power alpha x is the same thing. So you have to solve this one using what? What method do you think you use? Anybody? Integrating factor.
Integrating factor.
Yes or no?
Yes, yes.
Yes, sir.
What is your P in integrating factor here is 2.
Yes.
Solve the integrating factor, substitute it in the general formula, you get it. Then look at it. They already told you initial value problem. This is the y dx equals to 12x raised to power 3 minus 2 sine x. When your y of 0 equals to 3, that's all. That is how you read it. Look at this. The next question says the y dx, that is y prime minus y equals to 2 in bracket 1 minus x. Look at the solution. Is y equals to 2x plus c exponential x. They now ask you, this is y complementary. They ask you to find y particular of the same problem. Over to you. So guys, go and practice it. It is possible. Now, where they have the degree of differential equation here, this is the cube.
Sorry,
Yes.
sir. This one you told us now we should practice. What will be the answer so that even when we are through, we'll be able to know
You
that,
can solve it once you use the method that I use in the notes. You will surely pick the answer here. I'm not telling anyone. I don't need to tell you, because these are the simplest one. Compare the one in your notes.
Okay.
So if I tell you this answer is 1, answer is 4, I'm not helping you. Work it out by yourself. You will know the answer.
Sir, I don't know if you have sent this past question to the group before, the WhatsApp group.
Which one?
This one that you are reviewing right now.
I don't need to show you. It's there in your portal. So
No,
you
no,
don't have the
He
white.
sent the link last week.
I sent the link. The
sent
link is there. Go and
Okay,
type it. MTA 232. You will see all the past questions there.
Okay, thank you, sir.
They are there. You can type other courses too. They are there. So this one, I'm just teaching you how to read in case your question comes out this way. This one means forget about left, right that you see here. They are just for the brackets, parentheses to close it. So it simply means the y raised to power 3, the s raised to power 3, all square. That is, you open the bracket, you put the y raised to power 3, over the x raised to the power 3 all squared. Plus, yes, Charles.
Sir, please, are the questions going to be written like this?
I don't know. You guys complaining that this is the way they normally, your question is always scattered. And I'm just teaching you the clue, how to read the one that is scattered.
Yes.
Are you getting it now? The question is supposed to come in this way. This way. This is how it's supposed to be. Are you getting it?
It's small now.
Should in case the all things scatter, this particular question that I highlighted, we solve it in class. Charles, you remember?
Yes, yes.
Virtually all these questions, we've solved some of them. Lay your hands on it and solve them. They are simple. But if you join the background, okay, which method are we used for this one now? We just discussed it this morning. Y prime prime plus minus 4y equals to 12x.
This should be undetermined coefficients.
Undetermined coefficient, God bless you. Whereby you have m squared plus this, and you now equate it to be 0. And that is how you solve it. Now, we solve this one too, Rakati equation. Yes or no?
Yes, yes, we did that last week.
Last week. They are all there. So it depends. Just go and learn the method. The question here, the person that solved the question said the question even brilliant, telling you solve the Rakati equation. You already have idea the way Rakati equation look like.
Yes, yes.
Use the method to solve it. That's all. This one too, they said you have 100 grams of sugar cane, of cane sugar in water and being converted into diatosis. Go and check your notes. This particular application is there. How do you write it? The way we explain it, the y, the x, they said is converted. Amount unconverted is what? Find the differential equations, write it in differential way. And this one too, we solve something like this. This one, they will come. All these applications will also come. Go and learn it. Look at the way they represent it in your notes. Look at the one I solved in the class. Which year is this one? 2017. So I don't know the way they will do the one of 2022. This is 5 years ago. My people, I hope my little